I am explaining about shear force diagram. Now, we start the argument about a long and thin beam. The appearance is not so different from a bar. The difference between a beam and a bar is that we do not stretch a beam. In other words, in the case of a beam, we do not apply load along the longitudinal direction. In the problems of beams, we are considering the behavior of a bar exposed to the loads applied toward a direction vertical to the longitudinal direction. You may understand that we call this long and thin structure as a beam to distinguish this type of problem from the problems of tension and compression of a bar. Here is a beam OA. We take the x-axis along the longitudinal direction and then the z-axis downward. The length of the beam is L and the load P is applied to the tip of the beam. We are now considering the shear force acting in the beam. Just imagine that we are cutting a beam at the location of X. Then we get a beam of length L minus X in the end of the beam. On the right tip of the beam, a load P is acting downward. This is the initial understanding of beam analysis. First of all, as the premise, this beam does not move. Without a balance of forces acting on the beam starts to move. Now, the load P is acting downward at the cross-section on the right and the beam is not moving. To realize this situation, another load P must act upward on the cross-section on the left. For the tip section of the beam not to move, P must act in balance with the load P at the end of the beam. This P is the shear force described above. Now, the load P is acting downward at the cross-section on the right and the beam is not moving. To realize this situation, another load P must act upward on the cross-section on the left. For the tip section of the beam not to move, P must act in balance with the load P at the end of the beam. This P is the shear force described above. The cross-section on the left, which we are focusing, is the negative surface. So, since the shear force acting on the negative surface is now toward the negative direction along the z-axis, the shear force P acting on this surface is a positive. Now, we understand that a positive shear force P is acting on this cross-section. In the case of this beam, no matter where on the x-axis we cut it, the shear force P is acting in the same manner. So, the distribution of the shear force is constant at P. The diagram shows the distribution of shear force. Such diagrams are called SFD, shear force diagram. One may show the distribution taking x-axis on the diagram. Remember that the shear force diagram, or SFD, shows the distribution of shear forces along the beam. Here, the P that appears on the cross-section is an internal force. Equivalent amount of load should be transmitted to the left to right at the cross-section. Their direction is opposite, which is an action-reaction relationship. an equivalent amount of load is transmitted. Downward shear force of P, which is the reaction of the force at the tip, acts on the positive surface at the location of X on the left side of the cross-section. So far has been the outline of distribution of shear forces.